Assalamualaikum and good day. Right, so for this video, I'll show you tutorials on how to use the Quartus Ii software. So basically for this software, you can use for designing sequential combinational logic circuits, either in the block diagrams, or you can use the Verilog codings. So for this video, I'll show you on how to construct the circuit in block diagram. So as you can see here in this diagram here, shown the circuit diagram of a light controller, which it is a simple controller which consists of 5 basic logic gates, as you can see, which is here. And then you can see the truth table of the circuit, which are listed down here. So if you compare the block diagram with the truth table, you can see that there are 2 inputs, which is x1 and x2, and then you have one output, which is labeled as F. So from this truth table stated that if the inputs are in the same level, which is 0, 0 and 1, 1, the output of F will become 0. Whereas if the input are different, for example here 0, 1 and 1, 0, the output will become 1. So in this tutorial, I will show you on how to design this circuit and then to obtain the output which will follow the truth table here. So you have to prove it. You have to prove that the circuit is related to this truth table. Okay, so to open the software, just go to the start button and look for Quartus Ii Web Edition. So once you have clicked the button, the icon, and then this software will load up and you'll be introduced into the getting started with Quartus Ii software pop-up windows. So you can cancel this out, because basically what you can find here is the thing that I will show you. I'm going to show you in this video. This is the same thing. Okay, so you just cancel out this part here and wait for it to load completely until you obtain the windows, something like this. Okay, as you can see, you have entity toolbar here, the project navigator. Here you have the task toolbar, and here is the report, the messages toolbars. So this is where your creation of your circuits will be done, right? So basically this software is a direct software which you just have to pick and drop all the gates that you'll be using and just make the connections between them accordingly as how you can see on the diagram. Okay, so how do you start to create the file? The file that you are supposed to do is you have to create the project wizard first. So how do you do it? You have to go to the file toolbar there. On the toolbar, if you look for file and click on it, you'll find the new project wizard option. Okay, so click on that. Click on the new project wizard options, and the new project wizard pop-up window will show up. Okay, so here it will tell you what will be done. So what you'll be doing during this new project wizard here. So you'll be naming the project and create a directory, and what is the top level design entity, project files and libraries, what are the target device families, and as well as EDA tool setting. So you just click on next if you are here, and then you'll come into the second part, the page 1 of 5, where new project wizard directory name top level entity. So here, alright, defaultly the working directory for this project will be stated as shown in this video here. So C Altera 91 Quartus. So to design a new circuit, I would suggest to you that you have to create a new folder under your name, so it is easy for you to locate all your files in one folder, and it is easier for you to arrange them. So I would suggest that you create a new folder. So as here, I create a folder under my name. So put the backslash first, and then followed with your name. So this is my name, Izwan. So this will be the directory where all your files will be saved. And then on the second rows here, it asks you to enter what is the name of this project. So as for this one, I would like to name it as test, because it is a test circuit and it is a tutorial for you on the introduction of using the software. So I name it test, and note that whenever I put the name on the project rows there, the top level entity, which is the third rows, will follow the same name that I've used for the project name. So for this one, you just let it be. Let the top level design entity is the same name with the file of the project. Okay. So after that, you can proceed to next, and you'll come into the page 2 out of 5. If you are about to add any files, so as for introduction here, you don't need to add any files. Just proceed and click on next. Okay. Okay, here, this is where you have to determine the device family and the available device that you'll be using. So basically, for our purposes of using this software is actually to use it with the DE2 board. So the DE2 board that which are available in BMI is using the Cyclone 2 family. So make sure you select the family devices to Cyclone 2. Okay, so once you have done that, now we have to select the available device, which device you'll be using. So actually, as you can see here, I've selected this one. Okay, alright, but it is quite hard to find if you are looking through one by one of the devices name. So what I can suggest to you is you look into the user IO. This is user input output. So you click on them here, and it will arrange the number of the user input output port here to become ascending. Okay, so you look for the first one with the value of user IO 475. So that will be your device to be used. Alright, so proceed. Once you have choose that, click on next. You will go to the EDA tool setting. So for here, basically we are not using anything, so just leave this empty, proceed with next. Then we'll go to the summary page where it will tell you what actually you have done during this new project wizard. Okay, so here we have the project directory. As for me, it is my name. The project name is test. The top level design entity is also test. Okay, and then the family device, family name that I'm using is Cyclone 2, and the device name is these numbers here, right? Okay, so means that we have come to the summary page, means that we can proceed to the designing page. Click on finish, and then you can see here what are the files, what are the things that you have done during the new project wizard. Okay, the family that you are using, the device that you are using, the name of the file that you are creating. Okay, okay, now we are about to start creating the circuit, the light circuit just now. So to design the circuit, we need to create the block diagram file first. So how do you obtain the file? You can go either to the file toolbar, and there the new tabs, you can click on that, or you can simply find it on the tab under the file toolbar, which is the white tab there. That is also for new. So once you click on that, it will give you selections of what are the new files that you are about to create. So here you can see lots of files which you can choose from: design, memory, verification, and other files. So choose for the design files of block diagram and schematic file, this one. Okay, so this will be the place where you'll be placing all your gates to construct as how shown in the figure just now. Then click on OK. So now you can see the new interface of this constructing window here, which looks like the breadboard of your breadboard lah, right? So you can see here, this is where you'll be placing all the components, and you can make the connections, and then you can make the input and output ports so that you can simulate them to obtain the output. Okay, alright, first one, what we have to do is, of course, we have to make sure on the circuit, which circuit that you are creating. So we look back into this diagram. So there are two AND gates of 2 input, 1 2 input OR gates, and 2 NOT gate. Alright, so you have to take them out, and then we can start placing them on the software just now, so that you can make the connection of this circuit. So back to the software. Alright, so to look for these components, or means these logic gates, on the left hand side toolbar there, you can see there is a tab, there is a button there, which is known as the symbol tool. So that is where you can find all the logic gates, all the primitives, all the input output ports that you'll be using in constructing this circuit. Yeah. Okay, so go ahead and click on it, and then this window will pop up. Then to find the components which you will be using, which is the logic gates, you can find them by expanding the libraries of Altera as shown here. So you expand it, you'll find three options: mega functions, others, and primitives. So all the logic gates and the input output ports can be found under the primitive folder. So expand it, and you can see another 5 subfolders, which is the buffer, logic, other, bin, and storage. Okay, so these logic gates will be under the folder of logic. So once you have expanded the logic, you can see there are lots and lots of files which are representing each component. Okay, for example, here you have N12, N2, N3, N4, and so on. Okay, so you can check on them what are they by clicking on their name, and the diagram here will show how exactly they look like in the software. So basically, N2 stands for AND gate with 2 inputs. Okay, N3 is AND gate with 3 inputs, and you can find everything in there. So as shown in the diagram before, we are using the 2 input AND gate. So click on the name and then click OK so that you can place them here. Right? So notice that from the diagram, you are using two input AND gates. So place 2 of these gates together. Okay, and then to end it, you have to right click somewhere on the interface of the software, and then click on cancel. Alright, so now as you can see, there are 2 AND gates with 2 inputs in your circuit, and then you still need another 3 gates, which is the NOT gate, 2 of them, and then the OR gate, 1 of them. Okay, so you still the same way, still can find them through this button, symbol tool, and click on it, and then under the same subfolder of logic, look for NOT gate. Okay, so once you click on the name, you can see how the actual gates look like here. Alright, so that is how it looks like. So this is the gate actually that you are using. So select on it and then click OK. Okay, same as how you place the AND gates just now. So now you use the same method to place them anywhere on the software first before you end the selection. Okay, so this is the second one. Alright, and then I want to end them, so right click anywhere on the software and then click cancel. Okay, so now you have already got the first four initial gates, the 2 NOT gates and 2 AND gates. Right, so as you can see now, I highlighted all of them together. Alright, so that it is I can use these highlighted gates for easily moving them. So just pull them to where you want to place them to make them look neatly. Alright. Okay. So it is up to you how do you want to arrange the position of the gates. But actually the position doesn't matter as long as the connection is correct, then it is okay. Alright. Okay, so we go back to the diagram here to look back on the connections. So as you can see here, the first AND gate, one of the input came from X1 and one of the input came from X2, but the X2 input is inverted first before entered the first AND gate. Okay. Same applies to the second AND gate. One of the inputs comes from X2 and the second input comes from X1. But the X1 input is inverted first before it is entered to the AND gate. Right? So back to the software. Try to make the connection on how shown in the diagram. But first of all, as you can see here, we only have these 4 gates. We don't have the input port for X1 and X2 yet. Okay, so how do you import the X1 and X2 input? Still go to the symbol tool, click on it, but now you close the logic folder and then you expand the pin folder. Alright, so here you can see there are 3 selections: variable, BDIR, input or output. So obviously X1 and X2 will be the input ports and F will be your output port. Okay, so click on the input port and then click on OK and place them somewhere here. Alright, where it will become the initial input of your circuit. Okay, and then the second one here. Alright, so you have 2 inputs, X1 and X2. So you can use them, these pins, to represent both of the inputs. And then to end them, click on cancel. Okay, and then refer back to the diagram. Here we still need one more gates, which is the OR gates, and then the output ports for F. Okay, so we go back and we look for the output port and place them here, because this is where your output of F will be obtained. And then click on cancel, and again look for the logic, because I forgot to bring out the OR gate just now. So bring the OR gate and place them before the output port, and then click on cancel. Right, so as you can see now, I'm arranging them so that it is easier for me to make the connections as how shown in the diagram. Okay, so I check back and I want to make sure how the connection should look like. Okay, how are the inputs of each gates and where the output will be going. Okay, right, so now I'm about to connect the gates here, but first I would like to arrange them like this. Okay, then now the first input pin, which is X1, will be the first input for the first AND gate. So you just make the connections by pointing at the end of the input port and click on it and drag them to the input port of the AND gate and click on them. Okay, so you should see the blue lines, which indicates that there are connections between the first pin input and the first input of the AND gate. Right, and then you may repeat the same method for all the other gates until you have created the same connections as shown in the diagram just now. Okay, so as you can see here, this NOT gate, you can rotate them to make it easier for you to create the connections. So here I rotate them by 90 degrees, and I place them here so that the input of this NOT gate will come from X2 and the output will be connected to the second input of the first AND gate. And then for the second AND, I will rotate 270 degrees and I place them here so that I can make the connections where the input will come from X1 and the output will be connected to the second input of the AND gate. Okay, and then you can arrange them as how you like, as long as they are neat. Complete for the next stage for the input of the OR gate. Okay, alright, then another one. Alright, perfect. And then the output port of F connected from the output of the OR gate. Okay, so here as you can see, the circuit is completed, and you can compare with the diagram here. Okay, so basically, of course, it doesn't look alike in terms of the arrangement and the drawings, because this is just a basic drawing by using writing softwares. Okay, but as long as the arrangement is similar, then there are no problems. You can proceed with the next step of designing this circuit. Okay, now you want to change the name of the input. As you can see here, for the first input port, it is named as pin name. So we want to change them to become X1 and X2, and then the output becomes F. So you double click on it, on the pin names, change pin names to become X1, and then click OK. And then the second input port, change it to X2, while the third one, change them to F. Okay, and now you are ready. Just have to make sure the connection is correct, all the name of the input and output ports are correct. Okay, then we can save them so that you can compile to check whether there are any problems with your circuit. Okay, when you have saved them, click on Save As. Make sure the name here is the same name with the one that you have created during the new project wizard just now. So let it be test. Okay, same name, and click on Save. Okay, and then we can start the compilation. where this compilation process will determine if there are any errors in your circuit. It will check and it will tell you if there are any errors, if there are any warnings, or it is okay. Okay, so you can find the compile button, which is here. Okay, the purple triangle button, or you can find them under processing, the start compilation button here. So either one. Alright, so click on the start compilation, then the compiler will start to compile and it will check if there are no errors. So just let it be. You don't have to do anything during this compilation process. Wait until it tells you that everything is done. Okay. Alright. So when it is done, the pop-up windows will come out and tells you that the compilation is successful. Full compilation basically is successful with 4 warnings. Alright. So if there are successful and you have some warnings, you can basically ignore them. Okay. But if you have errors, which means here they will be written in red colored writings. So that is the error. There are errors in your circuit, then you have to check them back, and then you have to make sure that the error is replaced with the correct one before you compile it again until you have this full compilation was successful window pop out. Alright, so unsuccessful compilation means that you can't proceed to the next step. So make sure you have to obtain the compilation to become successful. Okay. Alright, so once you are here, then you just click on OK to close the pop-up window. Okay. Okay, all the errors, all the warnings you can find here. But for warnings, you can ignore them. If there are errors, then you have to make sure you change them. Okay. Then now we are about to create the vector waveform file. So basically, this is where you are creating the output waveform from the input waveform, which you have to create it by yourself. But the output waveform will be linked together with the circuit that you just created just now to obtain the output. Okay. So the same way how you brings out this block diagram window just now. Okay, so you click on the file button here, look for new, or just this white new button, click on it, and now under the verification and debugging files, you click on vector waveform file. Okay, just now it is the block diagram and schematic for this one. Now the vector waveform file is for the output waveform. Click on OK. Then this window will come out. Alright. Now, basically, before you create anything here, you have to make sure you have to set the there are some settings that you have to do before you can proceed. Before you can proceed. Alright. Okay. Of course, first of all, we have to set the end time. Okay. Right. So in this vector waveform file, what we are about to do is we want to make sure that this table here can be proven, okay, according to this circuit. Okay, you have drawn this circuit, you just want to make sure this table is proven with the circuit that you have created just now. Okay, so this is where it will be proven here. Okay, now to obtain the input and output ports that you have used just now, which is the X1, X2 and F, you have to follow these initial steps, where you have to go to edit and click on the end time. So this is where basically you'll be setting the end time of your simulation. So for this one, I'll set them to 50 nanosecond. Okay, then click on OK. And as you can see here on the time toolbar, you can only see from 0 until 30 nanosecond, right? So 50 nanosecond is here. So to make sure that you can see them in one window, what you have to do is you click somewhere in the middle here and go to the zoom and click on fit in windows. And now you can see the time toolbar there showing from 0 until 50 nanosecond. So from the start of the simulation until the end of the simulation can be shown. Okay. Then we go to assignment, click on setting. Okay. So here in this part here, or basically you have to go to the simulator setting category. Okay, so here you look into the simulation mode. As you can see, the simulation mode, there are 3 types of them. Okay, which is timing, functional, and then timing using fast timing model. So make sure you change them to functional. Okay, functional means that the software, the circuit you have created will simulate regardless of the time. So there will be no propagation delay time and so whatsoever. So the output will become perfect. Alright. Then click on OK. And then we are about to import the input and output ports to the block vector waveform file here. So you go to edit, go to insert, click on insert node or bus, and then click on node finder. So the node finder window will pop out. Okay, under filter, click on pins all. Make sure this is selected, yeah, the pins all. And then you go to the list button and click on it. So it will find any pins which still not in use, which is the one that we have created just now. Okay, F, X1 and X2. Okay, so now what you have to do is you highlight all of them like this and click on this button here to make sure that it will be selected to the selected nodes. So these 3 is the same one with this node here. Okay, and then you can click on OK and then OK again. Now you can find all of the waveform of the input and output ports. You have F, X1 and X2. As you can see, the F waveform is in forms of this cross symbol. Means that it is unknown, because this waveform can only be obtained from the given input here. Okay. Alright, so basically what I want to do is I want to arrange the output to be on the bottom part. So just highlight on them and drag them down. Okay, so x1 and x2 is the input. As you can see, both of them are in zeros. Okay, so you want to make sure that you don't have to do any changes on this F waveform. You only need to do for x1 and x2. Okay, so look back to this truth table. We have 4 possibilities: x1 and x2, 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so 0, 0 output is 0, 0, 1 output is 1, 1, 0 output is 1, 1, 1 output is 0. So that is what we are about to create, this input here for x1 and x2. So what I have to do is just make sure I can show all of the possibilities. So this will be 1, this is 0, 0, this is 0, 1. So x2 to becomes 1, you highlight on it and click on this 1 button. And then the third one is 1, 0. So highlight x1 from 20 nano to 30 nano and click on 1 as well. And then 1, 1 for 30 nano to 40 nano. So highlight both of them, x1 and x2, and then click on 1. So now, as you can see, you have here 0, 0, 0, 1, 1, 0, 1, 1. Okay, which if you compare here, it is fulfilled. Okay, 0, 0, 0, 1, 1, 0, 1, 1. So now this output, you don't have to set them here. So let them be for F. Let the compiler obtain the output automatically from the file here, and this one will be linked together. Okay, so now this waveform file, you have to save them. So click on File, click on Save Project. Make sure the name is the same as well, Test. Okay, click on Save. And then now we are about to simulate the circuit that you have done. Alright, but before that, there is one more thing you have to do, where you have to go to the processing and then click on Generate Functional Simulation Netlist. Okay, so it will generate netlist to link between both of the test file, the waveform and the block diagram. And then it will tell you the functional simulation netlist was successful. Okay, so then you proceed, click on OK. Now you are about to simulate them. So go to processing, you can click on here, start simulation, or this blue triangle. So click on them, it will simulate and the output will be obtained. So here, as you can see, okay, from here, as you can see, this waveform obtained, the waveform of F has already been generated from this initial one that you have done just now. Okay, so F is crossed, and then this one, F has values. Okay, so now you can check 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0, 1, 1 is 0, which satisfy this truth table. Okay, so it means that your circuit is correct, as well as for your waveform is also correct. Then your waveform, which you have done just now, prove that the output obtained is the same as how the truth table of the circuit should be. Alright, so that's it. That is the end of this video. So if you are here, means that you are ready. You have already finished this tutorial. Okay, so good luck. Use this as your reference for your labs. Thank you, and Assalamualaikum.